measuring yield curve risk. Now we are on section 7. How did we measure interest rate risk in level 1? We talked about duration, and specifically we focused on something called effective duration. But effective duration only told us about parallel shifts in the yield curve. Is that still important?
Yes.
It is still important, but is it complete? No, and we'll get into detail. So effective duration only measured the impact of a parallel shift in the yield curve. And Basit, what was the most basic interpretation of duration? The percentage change in price or the actual change in price? Yeah, so the most basic interpretation of duration was that if there is a 1% change in yield, what is the percentage change in the price of your bond or bond portfolio? If the duration is 2, what did that mean? A duration of 2 meant that if interest rates go up by 1%, your bond portfolio will go down by 2%. And again, the assumption when we say yields go up by 1%, what we really meant was yields across the maturity spectrum go up by 1%. Okay, so that's what we did earlier. Now, when we talk about yield curve risk, we need to, in level 1, we just memorized that yield curve risk has something to do with changes in the shape of the yield curve. Now we are going to get a little deeper, because let's say we have a situation like this. So initially you have this yield curve, and then your new yield curve looks like that. Okay, so this is the old and this is your new. So what is this sort of a movement called? This is a twist. Okay, what's happened in a twist? Is there a parallel change? Yeah, actually the way we can look at it is this is a combination of a parallel move plus a change in slope. Okay, but the core point is that short-term maturities did not go up too much, but long-term maturities went up a lot. Okay, let's just make this a little more extreme. Now, why is this important? Let's say, I'm just going to set the context, and then all the calculations we'll do will make a lot more sense. Let's say we have 2 different banks in here. One bank has a bond portfolio that is mostly, let's say 95% in short-term instruments, whereas another bank is, for whatever reason, mostly invested in longer-term instruments. Okay, now when this happens, one bank will be fine with this change, the other bank will be very unhappy. Which bank will be fine and which will be unhappy? Yeah, so the bank with short-term instruments will be fine because interest rates only went up a little, so the bond value will only go down a little. Whereas the bank with long-term instruments will have a big problem because there has been a big change in interest rates. That's one punch. That's the left punch. What's the right punch? The fact that long-term bonds will also have a greater duration. Okay, so clearly we need to worry about not just a parallel shift, we also need to think about the change in shape of the yield curve. And the risk associated with any sort of movement of the yield curve is called a yield curve risk. Okay, now we are going to get into something. The really diligent ones among you would have read something like key rate duration in level 1, but very few people actually understand what that means. How many people understood what key rate duration meant in level 1? How many people actually remember seeing it? Okay, so diligent means that you saw it. If you actually understood it fully, then you'd be a genius, because it's not actually properly explained there. Okay, now we are going to, at level 2 you have to understand. A common approach to measuring yield curve risk is to change the yield for a particular maturity of the yield curve and estimate the sensitivity of a security or portfolio to this change, holding all other key rates constant. We are actually going to build an argument here. The most basic interpretation of a key rate duration. Okay, so I'll read this and then move on. Key rate duration is the sensitivity of a portfolio's value to the change in a particular key rate. Now, can you think of this? You have different rates here, the 6 months rate, the 1 year rate, the 2 year rate, the 5 year rate. Different rates are changing by different amounts. So can we say something like this? Can we say that the 2 year duration is equal to, say, 3? What this is saying is, let's say you have a bond portfolio and you want to measure the duration of that portfolio. So you can make a statement that only if the 2-year interest rate goes up by 1%, then what's the impact on my portfolio? Anything wrong with saying that? Nothing wrong, right? So you can say if only the 2-year rate goes up and all other rates stay the same, then what happens to my portfolio? Okay, you can easily say that. So you can think of so the answer that you will get will be called the key rate duration, where the key rate is the 2-year rate. Now, if we can do that for 2 years, can't we do the same for 3 years? Okay, we could do the same exercise for, say, then the next thing we can say is, if only the 3-year rate goes up by 1%, what happens to what's the percentage change in my bonds value, and so on and so on. Okay, and we are going to actually do an example and make sure you get this. The most popular version of the key rate duration actually uses 11 key maturities of the spot rate curve, and those 11 are given right here. And then it takes a average. So for example, to keep it very simple, let's say that you have in your portfolio 11 bonds. Let's say that your portfolio is $11 million. $1 million is in 3-month bonds. The next million is in 1-year bonds, and so on. Okay. So one thing that we can do is simply figure out the duration, the key rate duration, where the key rate is the 3-month rate, then the 1-year rate, then the 2-year rate, and then add it all up. Okay. I don't think most people actually understood that, so this has to be understood. Hopefully you got a vague idea. Now to understand it, let's go through an example. And this is precisely from the curriculum. The guy who came up with this whole concept of key rate duration, it is his work that we are looking at right now. So to understand the concept through a simple example, what we are going to do is, so to simplify the key rate duration methodology, suppose that instead of a set of 11 key rates, there are only 3 key rates. And if you can understand this concept, then the extension to 11 is just a mechanical exercise. So there are 3 key rates: 2-year rate, 16-year rate, and 30-year rate. Why are we only considering these 3 key rates? Because we are looking at 2 portfolios. Okay, let's say that we have $100 in portfolio 1, of which $50 are in a 2-year instrument, 0 are in a 16-year instrument, and 50 are in a 30-year bond. Okay, so do you understand portfolio 1? Very simple portfolio. So this is your portfolio 1. In portfolio 2, we have all 100 in a 16-year bond. Okay, so that's our portfolio 2. 2 different bonds, and you can notice that in our case, what are the key rates? The 2-year, 16-year, and 30-year. What happens to the 5-year rate is not important to us, so it's not a key rate in this context. Okay, so let's continue with our definitions. Let's also say that we define this thing called D1, which is the key rate duration for the 2-year part of the interest rate curve. What does this mean? What this means is that if D1, so what is D1? It's the key rate duration for the 2-year part of the curve. Do you recall that if you have a 2-year 0 coupon bond, what is the duration of a 0 coupon bond? Do you remember this? It is the same as the duration of, as in the tenor of the bond. So if it's a 2-year bond, 0 coupon, if interest rate goes up by 1%, by how much will the value of a 2-year bond come down? 2%. If you have a 16-year bond and interest rate goes up by 1%, the value of the 16-year zero coupon bond will come down by 16%. So the duration is equal to for zero coupon bonds. And for simplicity, we have assumed that we only have zero coupon bonds in this example. Okay, so what does D2 mean? It is the key rate duration for the 16-year part of the curve. So what do you think? So what's the interpretation of D2? So the interpretation of D2 is that if the 2-year rate goes up by 1%, then what will happen? So what will happen to the value of our portfolio? Okay, now let's go through the rest of this example. Let's focus on portfolio 1. What was portfolio 1? It was 50 in the 2-year issue and 30 in the 30-year issue. Do these numbers make sense? That as far as the 2-year issue is concerned, what will happen if the 2-year interest rate goes up by 1%? The value of the 2-year bond will come down by 2%. So the duration is 2. What will happen to the 16-year bond? Okay, so duration of the 16-year bond is 16, duration of the 30-year bond is 30. Okay, for now don't worry about this. Okay, now let's look at it this way. What will happen to portfolio 1 if only, what did D1 stand for? Duration of, yeah, so this stood for what happens to the portfolio if only the 2-year rate goes up by 1%. So what will happen to portfolio 1 if only the 2-year rate goes up by 1%? Okay, what will happen is, so what was our portfolio? It was 50 in the 2-year issue and 50 in the 30-year issue. So if only the 2-year rate goes up and nothing else goes up, then you have a duration of 1. Why is that? Because, yeah, it's 50% of the portfolio. So if so this is the calculation. So you have 50 over 100 because your 2-year bond is 50 out of 100. What's this to? Duration. So this key rate duration is 1. The interpretation of 1 is that if the 2-year interest rate goes up by 1%, then the value of the bond portfolio 1, will come down by 1%. What if only the 16-year rate goes up and nothing else goes up? There will be no impact because in this portfolio there is no 16-year bond. D3 stood for what happens if the 30-year rate goes up. If the 30-year rate goes up, then obviously you have 0 over here, 0 over here, but here you have the other 50% of this portfolio. 50 over 100 into 30 is equal to 15. So what this is saying is, if only the 30-year rate goes up by 1%, then the value of the portfolio comes down by 15%. Is that simple? Okay, for now just take my word for it and later you will see why. The effective duration is simply the sum of 1 and 16. But at this stage we'll say the 1 year or the 2-year key rate duration is 1. The 16-year key rate duration is 0 and the 30-year key rate duration is 15. Okay. So how can we calculate? Now let's see if you can do this exercise. What are the key rate durations for portfolio 2? Yeah, so what would for portfolio 2, what would D1 be? So if the 2-year rate goes up by 1%, this would be 0. What about D2? If the 16-year rate goes up, then the value of the bond portfolio will come down by 16%. And what's D3? 0. So actually, in both these cases, are the key rate durations the same? No, the key rate durations are different, because for portfolio 1, what was this key rate duration?
1.
It was 1. For portfolio 2, what's the key rate duration where the rate is, the 2-year rate? 0. So notice that the key rate durations are different. But the effective duration, which is simply the sum, effective duration is the same. Okay, now just let's continue with these numbers. Okay, we are going to look at different scenarios and see what happens to the two different portfolios. And these scenarios are going to be scenarios that involve non-parallel shifts in the yield curve. So the key rate durations differ for the two portfolios. However, the effective duration is the same, which is 16. Despite the same effective duration, the performance of the two portfolios will not be the same for a non-parallel shift in the spot rates. Okay, consider these scenarios, and we'll go with the curriculum example first and look at scenario 2 for portfolio 1. Do you remember what portfolio 1 was? So it was 50 in the 2-year, and in the 30-year we had 50, and in the 16-year we had 0. Okay, so let's take scenario 2. So portfolio 1, you have 50, which is in the 2-year, so in the 2-year bucket or 2-year bond. What happens here? The 2-year key rate shifts up by 50 basis points. Is this good news or bad news? Yeah, it's bad news for this bond. So by what percent does Sana, by what percent does the value of the portfolio go down? No, it's 10 basis points. Okay, so what was the key rate duration over here? What have we just established earlier? So we established earlier that if interest rate goes up by 1%, if the 2-year interest rate goes up by 1%, the value of the portfolio comes down by 1%. So if the interest rate goes up by 10 basis points, which is 0.1%, then by how much does the portfolio yield go down by? By 0.1%. Okay, still on portfolio 1, we had in the 30-year instrument, we also had 50. So the 30-year rate goes down by 10 basis points. Is this good news or bad news? This is very good news. Okay, so now what was the key rate duration over here? The key rate duration was 15. This 15 is saying that if interest rate goes down by 1%, the value of the portfolio will go up by how much? 15%. Go up by 15%. But what's happened? Interest rate has gone down by 0.1% or 10 basis points. So rates will go up by how much? 1.5%. So now overall what happens to the portfolio? Was this a non-parallel shift in the yield curve? It was a non-parallel shift, and this method of key rate durations actually allows us to figure out that overall we have gone up by 1.4% based on this non-parallel shift in the yield curve. Okay, what will happen to portfolio 2 in this scenario? Yeah, so for portfolio 2, there will be no change. Okay, so now can you, actually I'll come back to this if I have time in this lecture, but if not, what is our obvious homework assignment here? Yeah, so do scenario 1 and scenario 3. So if we have time, I'll come back to it, but it just requires a little bit of thinking, and the benefit of doing the problem exactly from the curriculum is that you can just check your answer with the curriculum. Okay, now this is something that I'm not sure, I don't know if Shweza mentions this or not. It's not explicitly in your learning objectives, but you need to, these different kinds of portfolios, you need to know their names. And once you've heard it once, for some reason, these just stick. Okay, there are things that stick easily and there are things that don't stick easily. This is one of those things that stick easily. Okay, imagine you have a portfolio consisting of different fixed income instruments. A ladder portfolio is one where you have different bonds and you have an equal amount invested in bonds of different maturities. Okay, so you have $1 million in a 2-year maturity bond, $1 million worth market value in 3-year bonds, $1 million in 5-year bonds, and so on. So this sort of a portfolio where you have an equal amount invested across different maturities is called a ladder portfolio. A barbell portfolio is where you have most of your money concentrated in a short-term, relatively short-term instrument, nothing intermediate, and then again a lot of money in long-term. Does this mean you have nothing invested in between? No, it just means, relatively speaking, most of your stuff is concentrated. And why is this called a barbell? Sort of looks like a, barbell, 2 big weights. Most of your weightage is on the edges. And then why is this called a bullet? So this is most of your money is invested in one maturity. Now to check your understanding, so Umar, so portfolio 1 that we just talked about, do you remember what it was? Yeah. What was it? So which one of these was portfolio 1? Barbell. And what was portfolio 2?
Bullet, 2016.
Exactly. So portfolio 2 was a bullet. Okay. Now if you have a bullet portfolio and with this sort of a portfolio, would you be worried if the 30-year key rate went up but other rates did not go up? No. Okay, so it's important to understand what sort of a portfolio you have. Yeah, so the point is that a ladder would spread the risk, but a ladder would obviously be hurt by a parallel shift, upward shift in the yield curve. Okay, now this is question 17 from the curriculum. Part A is for each portfolio, describe the type of the portfolio. So for A, B, and C, let's see if you can figure this out. So A has most of its stuff compressed here in the 10-year. So this is a bullet. Okay, what about B? Yeah, B looks like a ladder. And what about C? So this looks like it has a bunch of stuff in this maturity. And then you have 1.9 and so on. So this looks like a barbell. Which portfolio will benefit the most if the spot rate for the 10-year decreases by 50 basis points, while the spot rate for all others, so A will clearly benefit. What is the duration for a parallel shift? Now these were actually durations. So if you notice that if you add all these up, you will get the same number. You can look at the answer. I think it's about 6 point something. So if we have a parallel shift, then the impact is the same across all three. Okay. So now we are getting into the final segment. The name of this reading is Term Structure of Interest Rates and Interest Rate Volatility. So we've finished the term structure part and now we are getting into the volatility. Before we get into some detail here, what do we mean by yield volatility? Okay, so let me just make sure everybody's clear about this, because in the past it's something that's created confusion. Okay, what we mean by yield volatility is the following. Okay, let's say this is time, and if you take your yields on, let's take our benchmark 6-month T-bill. Okay, if you have a situation like this where we have the yield on our 6-month T-bill being about 13%, and then slowly it comes down to, so from 13% down to 12%. So this is the yield on the y-axis and time on the x-axis. So the yield is high, but is this volatile? The volatility is low, versus you might have another market where again over time the yield might be relatively low at 3%, but the yield is changing a lot from day to day. Okay, so in this case, the yield volatility is high. The yield itself is low on average, but the yield volatility is high. Okay, so that is, if the day-to-day changes in yield are high, then that means volatility is high. How do you think you measure yield volatility? You look at standard deviation. Now, the curriculum takes something simple and makes it very difficult. Okay, so those who are trying to follow the curriculum, I'll just explain it in an extremely simple way. I don't know whether Schwezer makes it easy or hard, but the concept is not very difficult. The idea is this. Let's say you look at several trading days over a month. Okay, and 0 means you are at the start of trading day 1. Let's say at the start of the day, the yield was on a given instrument was 6.6945. Then what does 1 mean? So this is the end of day 1 or the start of day 2. Has the yield changed? The yield has changed from 6.6945 to 6.69. Now what is this percentage change? How can you calculate that? Okay, just do this for me, those who have your calculators. When you go from here to here, what's the percentage change? The percentage change is what? So 0.0672 or, okay, whatever, 0.067%. Okay, so you effectively have what they show you over here. But instead of simply this simple thing, they show you this ugly expression. All that they have done, this ugly expression, and you can do this ugly expression also, all this ugly expression is doing is assuming continuous compounding. And if you are the mathematical sort, this will be no problem. If you are not the mathematical sort, then don't get twisted around by this. All you need to recognize is that effectively we are looking at the percentage change in yield from day to day. Okay, so if you are hung up with these e to the power of something and ln's, then just think of this as the percentage change from one day to another day. On the exam, they are not going to catch you on, A-level mathematics stuff. Okay, so now that you have all these numbers, take a wild guess. So you have these numbers over the 25 trading days in a month. How do you come up with yield volatility? You plug these into your program, be it Excel, be it your calculator, and you figure out the standard deviation. Is that easy or hard? That's easy. So you just take all these numbers, plug them in, and you get your standard deviation. What does the curriculum do for you? It goes through this entire big formula, explains the formula, does all the summations, and does all the standard deviation formula. But I really, I'm like 99.9% sure that you will not have to do an elaborate standard deviation calculation on the level 2 exam. But you need to know this interpretation. The interpretation, again, as a quick summary, you look at your percentage change in yield, and then those percentage changes, you find the standard deviation for those percentage changes. In my earlier example, what would the volatility here be? It would be extremely low because the percentage changes are very low. But in this sort of an environment, the percentage changes will be high, so you will actually have a high yield volatility. Okay. Now the next point is, the example that I just did was the percentage change for one day to another day. Okay, so the point, this point 0.062, this was a percentage change over what time period? 1 day. Now everything that we generally talk about needs to be annualized. So how do you take that standard deviation for a day and annualize it? What you do is multiply it by the square root of the number of days in a year. Now how many days do you have in a year? Well, it depends on who you ask. Some people might say 250 days. Some people might say 350 days. Some people might say 365 days. Okay, like some guys just thinking, okay, this many trading days. Other guys is just saying, okay, 365 days in a year. So different people will give you different answers for yield volatility, and you need to understand what assumption they are making. And you will see shortly why I am going over this. What is the other variable that can cause different people to give different numbers for yield volatility? The number of daily observations. In my earlier example from the curriculum, we had 25 daily observations. If I had used 10, would my answer have been different? If I had used, or let's say I just used these 4 days, would my standard deviation have been different? Yes. It would have been different. So clearly the yield volatility number that you see depends on two factors. One is how many days worth of data did you consider, and the second is your assumption about how many days there are in a year. Okay, and there are actually questions where people are making comments, like if you look at the curriculum, there will be somebody saying that, okay, two people are looking at the exact same market and giving two different numbers about yield volatility. Why? Okay, we've already talked about the two reasons. Okay, the next learning objective is covered here. It talks about the difference between historical versus implied yield volatility. The yield volatility that we just derived, do you think this was historical or implied? This was historical because we did it based on historical data. So by using standard deviation of historical yield changes, this is what we just did. This is intuitively easy to understand. Another method is called the implied yield volatility. The way you can think of this is, we've studied derivatives. Okay, we've studied options, call options, for example. We've studied call options on stocks. Okay, I'm just building up a very simple argument here. The value of a call option, does it depend on the volatility of the underlying instrument? It does. Can you imagine call options on fixed income securities? You can. Okay, so the value, if that call option is being traded in the market, then the call option on that underlying fixed income security will have a market price, which is given. Okay, now as we will see later, in the formula for coming up with the price of a call option, there are several inputs. What are those inputs? It's things like the call price, the time to maturity, the volatility of the underlying instrument. Of all the inputs, the only one that's not observable explicitly is the volatility. Okay, so you can imagine a formula where you have price is a function of volatility and several other variables, x1, x2, etc. Now, if all these variables are known and the price is known, you can from the formula figure out what's the implied volatility. Do you get that point? For those who didn't, I'll make this extremely simple. This is completely made up. Let's say that you have this formula. Price of an option is equal to the volatility multiplied by the time to maturity multiplied by the strike price. The real formula is a million times more complicated than this, but the point is as follows. Let's say that the price of the option is 3. The volatility is unknown. The time, let's say, is known as 0.6 of a year, and the strike price, let's say, is known as 95. From this, can you figure out the implied volatility? Yeah, so this is the other way of coming up with volatility, where you see what is the volatility implied by the current price of the call option on that instrument. So this is called implied volatility. What are the possible issues? You might have a model like this which is completely wrong. Okay, so if you come up with a volatility based on an incorrect model, then that's a problem. Okay, the other problem is that remember, actually you can't remember because you've not, those who've done FM at IBA probably recall the Black-Scholes formula.
Yes.
Okay, those who've seen the Black-Scholes formula know that one of the assumptions in there is that the volatility is constant. Okay, so we make this somewhat flawed assumption about volatility being constant in most option pricing models. Okay, so that's the other problem. As long as you know that, you are in good shape. Now the final point for this reading is forecasting the yield volatility. Okay, what do we mean here? Why are we doing this? So Omar, why is it important to forecast yield volatility? Actually, most things in finance are not concerned about what happened, but they are concerned with what is going to happen. So obviously, if you are going to invest somewhere, are you interested in what happened in the past, or are you interested in the volatility in the future? So very simplistically, how would you forecast what will happen in the future? By looking at what happened in the past. That's the simplest thing you can do. Now, this is a complicated segment, but I'm just going to give you what I think is the main information you need to know. When we just came up with our volatility numbers in this example, in coming up with the standard deviation, we need to come up with this mean value. So all our data, we need to come up with our mean value. And in our example, we came up with a mean value of minus 2.3. Okay. Now, if I tell you that we have a certain interest rate today, and even if we have a rather volatile market, next day the yield can go up or the yield can go down, right? So wouldn't it be more reasonable to just use an expected value or a mean of 0? Right? If you have a given variable such as a yield, actually our variable here is the yield. Is it the yield or is it the change in yield? It's the change in yield. Okay, now can the change in yield be positive and negative? And for all intents and purposes, the probability of it going up tomorrow or going down tomorrow is the same. So what is the expected value for the change? 0. Okay, so rather than just taking an average of the last 20 days or 5 days or whatever and come up with an arbitrary number, in our model here, wouldn't it have made more sense to simply use 0 for the expected value of our variable, where the variable is the change in yield? So that's one point. Okay, so that's when we talk about forecasting and we are using historical data, we are saying the mean value should not just be the actual mean of the last 20 days or how many ever days. Exactly. So bottom line is, theoretically, it's more appropriate to use a expectation of 0. The curriculum goes through a long-winded explanation, but this is the one-line statement in the summary, and I think that's all you need to know, that better to use 0. Next point, the simplest method for forecasting volatility is weighting all observations equally. In the model that we just did, we looked at the last 25 days worth of data, and we said that, did we give more weightage to the more recent volatility change numbers? No, we just did an average, so we simply weighted everything equally. So that's a simple thing to do. But would it make more sense to give higher weightage to the more recent numbers? So all that is being stated here is, a forecasted volatility can be obtained by assigning a greater weight to more recent observations. And then the final thing that I'm sure you will love, you can also use arch models to come up with this, but as long as you know that this is doable, even the curriculum doesn't get into too much detail. Okay, so that is it. You please practice the questions, do all the problems